and welcome to the short demo on creating joins with the gap analysis, which is a requirements driven approach used in Bird. So before we discussed in a previous video an overview of Bird transformations and four components of how we can visualize transformations, those being the data model, joins for products, output layer for a report, and filters. And today we'll focus on joins for products, the second step, and we showed those before in a visualization, as a 3D visualization here, where we see the top here, the input, the data model, and here we have the join for a product, loans and advances, and here we have an output layer, and lastly filters and aggregations to create the report cell. And in this visualization we see there was two products, or two joins for products, one being loans and advances, a little bit blurry here, and the other being non-negotiable securities as a second product. So if we go back to our presentation, so as an overview, we can say that by creating joins of data on the Bird data model, we are linking input tables together so that we can match the required columns of the output layer specific to each report. So again, if we look at the visualization, we see we're joining these top three together from the data model, abstract instrument role, instrument and party, to get loans and advances, and we see we ultimately want to have these columns in the output layer, and they already exist in the input layer, so carrying amount, you can see its lineage here, so gross carrying amount, gross carrying amount. So we want to find a way to get, for each product, the correct columns grouped together so they match the structure of the output layer. So a key part of this process is ensuring there's no gaps in the input layer. For example, if it didn't have gross carrying amount, we can't get a join with gross carrying amount to match the structure of the output layer. So this means that the enriched input layer and the enriched logical data model, by consequence, must contain all necessary columns to match the output layer. So at the ECB, the gap analysis supports both the creation of the joins, so it's linking a subset of input tables to match the columns required for the output table specific to the report. And these are stored as cube links and cube structure item links, which we discussed before. And at the same time, it also supports identification of missing fields in the Bird enriched input layer, and so in turn the enriched LDM. This is why it's called the gap analysis. Here's ECB's description of the gap analysis. So for example, when they integrate a new framework like FinRep into Bird, there's the process of mappings, gap analysis, and then this leads to interactions with the logical data model, with the Bird data modeling team to fill in those gaps, and then development of the logical transformation rules. Here we see again a sort of nice high-level overview of the gap analysis. So our starting point in the gap analysis is the output layer. That might seem like we're starting at the end, but the output layer itself, which we just showed in detail in a previous video, is created from the mappings between the EBA dimensions and members, which are used in the EBA annotated templates for FinRep, for example, and we show that we have the mappings between those and the SDD dimensions used in Bird, because Bird is using an SDD dictionary, FinRep is using the EBA dictionary, so we need to map between these two. And this means the approach is truly requirements driven from the report template, because we've considered the report, the EBA annotated template, and basically converted that into an SDD annotated template. So the steps of the gap analysis include identifying the relevant product for a report. And so in our example of FO5, these were loans and advances and non-negotiable bonds. And often these can be derived automatically from the report templates and mappings. So that's how we, for example, we worked out that loans and advances were one of the products involved in FINREP FO501. We'll show that a bit later. The second step is we just list the attributes in the bird output layer for that report. Very simple. And then we search for these attributes in the output layer for FL501, for example, in the input layer. But we do that search in the context of each product. So we might find gross carrying amount in one place for loans and advances, but in another table, input table, for non-negotiable bonds. So the process identifies missing data fields in the input layer, and each detected gap, we call this a gap if there's a missing field. For each one we raise an issue to the bird data modeling group as a GitLab issue, and this workflow has proven to be highly efficient, especially for finalizing FINREP in bird, so that we ensure that the data model is 100% fit for purpose as a source for the FINREP transformations. So we can note that the joins form a concrete link between the data model and transformations, and therefore to reports. And this is hard evidence that the data model meets the requirements. Again, if we look at our 3D visualization, the fact that we can show lines all the way to a report cell is indicative of the fact that the input layer can fully fulfill the requirements of the transformations for FINREP, the first step of which is to join the data together for products. So we note that the process also creates a join representation stored as cube links and cube structure item links in SM cubes. This is the methodology of bird. So as we mentioned before, rather than searching for column names like gross carrying amount globally in the entire input model, the gap analysis tool considers the product context. So, for example, the difference between loans and advances and non-negotiable bonds, and the attribute may reside in different tables depending upon that product. Now, to assist in this automation, the bird FINREP transformation group, which is a working group that was led by the ECB and composed of participating banks, they created a standard set of products, and for these a high-level join for each product, including, say, loans and advances. These are conceptual joins, so they don't go to a technical level of detail like SQL statements and inner joins and outer joins and left joins, etc. There's like high-level description, and they just indicate, for example, that loans and advances requires these four input tables: instrument, instrument role, party, and collateral. It doesn't say how they're joined together and if they're inner, outer, left or right or upside down. So to specify these joins and a high-level description of joins, we have configuration files. There's a file created by the working group, and in Freebird we have a configuration file that reflects that choice of joins. And we also, for each product, we show which type of instrument it relates to in SDD, and we'll show why that's useful. And so this supports the gap analysis execution within Bird and also within Freebird. So let's have a look at that configuration file in Freebird. So here's Freebird application, but we also see its configuration files. So here's a configuration file, and it said, for example, for the loans and advances product, we have a main primary table called instrument. It's a table in the bird input layer, but we also have these related tables: abstract instrument role, party, and collateral. And that helps the gap analysis to know, okay, I'll look in these four tables so that I can find the gross carrying amount, for example. Whereas for non-negotiable bonds, it's here. It looks in different tables. It looks in this one with the longest name ever, long security position, potential portfolio, etc. And also in party and in long non-negotiable security position. So it's a different set of tables to look in to find the gross carrying amount for that product. And the second thing we have is for each of these we say what is the type of instrument in Bird. So this is a particular variable in Bird, and we see that loans and advances and non-negotiable bonds relate to type instrument 149. So why is that useful? Well, if we look at the Bird website and we look at these, what we call the combinations of filters, which were derived from the mappings between EBA and STD, and we look at something like loans and advances, we'll see that it has a filter to say type of instrument is 149. And that 149 was the same thing we linked loans and advances to here. And so it's sort of smart enough to search through the templates and see, this uses 149, so it can be related to the loans and advances product. It's maybe 90% efficient. Occasionally it misses things, and there are some things that need tweaks, so we call it a semi-automated process because we always check the results manually of the gap analysis, but we let the automation do 90% of the work for us. So that list of joins and list of products and joins per product is available on GitLab, the ECB GitLab called SOFA. It's available for those with access to the ECB Bird Transformations repository, such as the FinRep Working Group have access to that. The cube links are published. We showed where they're published before on the Bird website. Let's have a look again. We see them in the metadata exports under cube link. Cube structure item link. It can be downloaded as CSV files. But we note in the ones that are published on the website, we've mixed together the different products. So for FO501, we mixed together both for loans and advances and non-negotiable bonds into one set of cube links. Is one way to do it. However, in FreeBird we've separated that, so we have one set of cube links for each product, like one for loans and advances and one for non-negotiable bonds, again per report. So if we looked at our visualization, these lines in red loans and advances to this input table is one cube link, and then to instrument is another, and to bird party is another. And these red lines relate to the cube structure item links, to actually link columns. Let's click on one. Carrying amount here goes to carrying amount there. But in green we have the cube structure item links for non-negotiable securities, which are a bit different. So here, for example, gross carrying amount went to gross carrying amount in a different securities related table. And so, in our opinion, it's nice to really differentiate between which product a cube structure item link is related to, whereas in the published, official published Bird version ones, it's more like it's linking from here the output layer directly to the input layer without a differentiation by product. Still works, but in my opinion it's better to have the clearer, more precise definition. So as at the end, FreeBird, we have a separate set of cube links for each product. So there are some, the gap analysis is not perfect, there are some pitfalls. So for example, the tool might identify multiple sources for a single output field. So it might find carrying amount in, I don't know, collateral and instrument role, for example, or it might find, let's look at an example. So in FreeBird we show this case. So here's the tool. We say after we created these joins, we can look at duplicate join items. we search by cube, let's say FO5, and it shows us here that when it was trying to find the institutional sector in the output layer, it found 3 possible places in the party table: institutional sector EBA, SHS institutional sector, and we can just choose one by deleting the others. Here it was looking for type of instrument, and it found instrument type origin in 2 different places: instrument type and type instrument origin. So for example, so here we highlight look at the duplicates and then delete the ones that we don't want, so we have this human in the loop there. Also, items that might be missed by the automated gap analysis if the configuration file is incomplete. So we forgot to put some things, tables that are used, like maybe the collateral table and loans and advances. And also if the output layer references unused input fields, so fields that just don't exist in the input layer, that might be because the gap analysis needs to add them, or it might be that we've made a decision not to use something like I don't know, held for trading indicator, for example. We might have chosen not to use it, but not updated the output layer. So we need to update the output layer, and to update the output layer efficiently, you need to first change the mappings, the semantic integration, so that the output layer is created in the correct fashion. So that's a summary of the gap analysis. It's and how it's used to create joins being a key part in the bird transformations and in FreeBird also. And this approach is very much driven by the requirements of the report. This is why we go from EBA, and then we map to STD, and then we map to input layer. So there's a traceability driven by requirements. I hope you find that interesting. Thank you for watching.